how do we score more than 90% marks and close to 100% in final exam? That is what you learn when you watch my videos. Since I take up questions which are based on past test papers, here is one for you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this series, we are doing test preparation on trigonometry. Most of the questions are from previous test papers or shared by my students. In this video, we will understand how do we write equation of a trigonometric function from given characteristics. So the question is, write equation in the form of y equals to a sine k x minus p plus q when maximum is at 240 degrees 3 and minimum is at 600 degrees, the value being minus 1. Well, some of you can provide 4 equations, right? Two in sine, 2 in cosine. We'll provide you with one solution here in this particular video and go through the complete steps involved in writing the equation from the given conditions. I'll also visualize the whole thing so that nothing is left for memorizing formulae, right? Okay. So we are given maximum is at 240 degrees, the value being 3, and the minimum is at 600 degrees, value being minus 1. So basically, we are given a sine wave. Let me sketch one here. So let us say something like this. Okay. 2 points talking about our maximum and minimum. Maximum being at 240 degrees and the y value is 3. Here we have 600 degrees and the y value being negative 1. Perfect. So this sine wave, how do I write equation for it? Well, we should begin with the average, which is right there in between, and that is also called the axis. So axis, which in the formula is given by q. What is that value, q? How do you find it? Well, axis is the center value. So add the y values, divide by 2. So maximum, minimum, divide by 2, right? So axis is basically add maximum value and minimum value and divide by 2. Correct. Makes sense. So that is the formula. Substituting the two given values, which is 3 and minus 1, dividing by 2, we get what? 3 minus 1 is 2. 2 divided by 2 being 1. So we got the value of q, which is equal to 1. So we got one parameter straight. Now from here, we can move upwards or downwards, taking out what is the amplitude. Amplitude, remember, is always positive, right? So amplitude is how far away are you from the axis, maximum. So both these values refer to amplitude. It is the difference between axis and maximum or minimum value, but absolute value, right? So now let's look into amplitude, which is written by capital A in our formula. And we can see from here, we could say axis, which is q, minus minimum, right? So axis is 1 minus 1, and that gives you 2, right? Oh, that gives you 2. So let me just write 2 here. So when I say 2, I know amplitude is 2, so I'm writing capital A as 2. Another value known to us. Now look into the time period. When we are given only maximum and minimum, it really gives us a time period of half the cycle, right? So half of the cycle is given to us. So from here to here, you see, this distance is how much? This distance is half cycle. So twice this distance is a period. Is it okay? Now, let us find out the time period. So time period for this wave is how much? Time period is twice this cycle, right? Twice the difference between maximum and minimum, I should say. So 600 minus 240. That is twice. So if you take away, you get 0, and then from 6, and then from 5, you get 2, 3. So that means 720 degrees. Time period is 720, and from here we can find the value of k, right? So what is k? K is 360 degrees divided by the time period. So in this case, it is 360 degrees divided by 720. And that gives you half. So the value of k is half for us. Perfect. So we got all these parameters, and now it is time to figure out what is the phase shift. Okay. So phase shift is a point from where the sine wave starts. We have to figure out where is that starting point, right? So now, as you know, the time period is 720. So, and sine wave is really starting from here. What is this time? This is what you need to figure out, right? So the total distance from here to there is 160, and that means from here to here it is, you can add 180 or subtract 180, right? So if I do 240 minus 180, I get the starting point, which is 60 degrees. Do you see that this point is at 60 degrees, right? Of course, we have found the axis value, which is 1. You get the idea. So if you see one full cycle, it'll be 60 plus 720, you get that end, right? Now, since you are here at 60 degrees, you can actually say that the sine starts at 60 degrees, this particular wave, right? So you can say that the phase shift is equal to, so let's talk about phase shift. Which is by lowercase p, is where the sine wave starts from the axis, right? So it starts from 60 to the right, so 60. So that is the value, 60 degrees. So once you get all this, you can substitute in your equation and get your solution, correct? Make sense? So we have a time period of 720, that gives us k value of half, and in the given situation. So now, can you write down the equation, please? So for the sine wave, we complete this solution and write down the equation as y equals to value of a, we just calculated 2, sine k is half, x minus p, which is 60 degrees, and the x is symmetry, x is moved 1 unit up, correct? So that becomes the equation for the given function, correct? So I hope the solution is absolutely clear. I would like you to actually write down 4 different solutions of this particular question, right? So here's a question for you. We are given the same conditions which we just now worked out. Now I would like you to write 4 equations. For the above conditions. Four equations will be of the form y equals to plus or minus a sine k x minus p plus q, or y equals to plus or minus a cosine k x minus p plus q. Make sense? Perfect. So that will give you more understanding of these concepts which we discussed in the video. Well, in case you want to learn from me, you can always send an email on the address given. Feel free to write your comments. Your valuable suggestions are always welcomed. Thanks for your time and all the best.